Okay, so for number 7, we're going to solve a system. We have 2 equations, so that's a system of equations. We want to find the points where these 2 functions intersect. So what I'm going to do is, since I have a quadratic right here, right, since this is x squared, I'm going to get the y on one side and all the x's on the other side. So I'll leave this as negative 10y, and I'm going to add 60 to both sides here. So I have negative 10y equals negative x squared minus x plus 60. All right, that's how we write a quadratic. Go from the highest exponent to the lowest. All right, and then now for this one, I'm going to subtract x from both sides, and I get negative 2y equals negative x plus 3, right? So now this is not the only way. There's all different ways you can solve this, all right? So if you do it differently, then that's fine. What I'm going to do is I'm going to make this one be a, if I multiply by negative 5, right? If I multiply by negative 5, then this will be a positive 10, and then when I add them together, I'll have 0 y's. And I want my y's to go away. I want to have one variable. I want one equation, and I can solve. All right, so I'm going to use the distributive property, right? I'm going to distribute this to everybody. So I have a new equation that would be positive 10y, right? Negative times a negative is a positive 10y equals, and then that would be a positive 5x. Oh, true. And then that would be a negative 15. Okay. And then now I have my red equation, all right, which was negative 10y equals, and then I have a negative x squared minus x plus 60. Okay, and I'm going to combine these together because even though the left-hand side looks different from the right-hand side, they're equal. And so technically I'm doing the same thing to both sides. So I'm going to combine these like terms, and I get 0y, which is just 0. And then I've got a negative x squared. Right, I'm combining my like terms, and I've got 5x minus x, so that would be a 4x. And then 60 minus 15 would be a positive 45. Okay, now I'm going to, when I have quadratic, right, this is a quadratic, I want to factor. All right, so I want to factor, so I want this to be a positive. No worries, I will just go ahead and multiply everybody by negative 1. Just like I can multiply everything by negative 5, I can multiply both sides by negative 1. All right, you just distribute, so negative 1 times 0 is 0 equals, now that just changes the sign. So this is a positive x squared, a minus 4x, and a minus 45. All right, and so now again, I have a quadratic, so I'm going to factor. All right, factors are in parentheses, and so now I want two numbers that are going to multiply to be negative 45. So I can go on my calculator, and I'll go to y equals, and I'm going to make this a negative 45, make sure you have the sign there, divided by x. And that gives me all the factors of negative 45. And then I want them to add up to be the middle term, which is negative 4. So I'm going to do x plus y1, right, the factors that I found. So alpha, trace, enter. I want the factors to add up to be a negative 4. So I'm going to go second, math, enter. So I want them to equal a negative 4. All right, and now when I go to second graph, I'm looking for the 1. That's my flag that this is a true statement. So 5 and negative 9. Okay. So the factors of x squared are x times x, and then I have a positive 5 and a negative 9, and that adds up to negative 4. And I want that to equal 0. Right, so I'm looking at x could equal negative 5, right? The opposite, right? That's positive 5, so a negative 5 would make that 0. And x equals positive 9 would make this 0 if I substitute in. Right? 9 minus 9 is 0, and negative 5 plus 5 is 0. So those are my two x coordinates, all right? Because remember, if I have a quadratic, and this is a linear because it's x to the first power, they have two intersections here. All right, those 2 points are my solutions. All right, and now I know the x coordinates are negative 5 and positive 9. Now I want to find the y coordinates, so I'm going to go back up to one of my original problems here. And this is definitely the easier one, so you always find the easier one, because then you make less mistakes, fewer mistakes. So I'm going to substitute in for x. So I have a negative 5, right? So negative 5, I'm rewriting this, but I'm substituting in. Negative 5 minus 2y equals 3. And then now I'm solving for y, right? That's what I'm curious about. So I want that by itself, so I'm going to add 5 to both sides. And so that gives me negative 2y equals 8. Divide both sides by negative 2. And so y equals negative 4. So when x is negative 5, y is negative 4. All right, and now I'm going to do the same thing, but I'm going to substitute a 9 in for x, right? Now x is 9, so I'm going to rewrite this. I'm going to say 9 minus 2y equals 3. So then I'm solving for y, right? I want the y by itself, so I'm going to minus 9. Oops, did I do? Oh, no, that's right. So I'm going to subtract 9. Right, because this minus goes with this 2. Right, this is a positive 9. So 9 minus 9 is 0. And I'll bring down my negative 2y. And then 3 minus 9 is negative 6. All right, and then I'm going to divide both sides by negative 2. That's 1. So 1y equals negative divided by negative is a positive 3. So when x is 9, y is positive 3, and this is my solutions. Remember, if you are solving a system, you get points, right? You get points of intersection. Okay, the intersections are the solutions. Okay, very good.